Hello, in this video we will take a look at an overview of section 4.2. In this section we're going to study limits and continuity. We'll first define limits as we've done before. Now the idea behind a limit is it becomes this complicated limit with an epsilon and delta. That is, for every epsilon bigger than 0, there corresponds a number delta, such that if you have your point xy in a domain and then 0 is less than, now this is really the distance between xy and the point AB, so that distance is less than delta, then the absolute value of that function f of xy, the difference between that and the limit that you're saying is going to be less than epsilon. Well, we're just going to take a look at this and maybe mess around with it a little bit, but we're not going to dive too deep into this particular definition. Instead, when we're dealing with limits, we're going to rely on some limit rules. And these are properties of limits that we'll be using to calculate limits. And in some cases, it turns out that calculating limits without using those rules would be a lot more difficult using epsilon delta. But to show that the limit does not exist turns out to be not such a bad idea, or not such a bad deal. To take a look at if a limit doesn't exist, in calculus 1, you remember you went from the left and went from the right, and then you got two different values. So that idea changes here when you have a function of two variables. Because there's a lot of directions to get to that single point. And so what we're going to do is take a path going to your limit, and the picture on the left here shows the path going to the limit and getting a value of 1/2 in that blue line. If we choose a different path, like we do in the second picture, the picture on the right, we'll see that we're going to get a limit of 1.5 this time. And so those two limits don't match. And so we're going to say that the limit does not exist in this particular scenario. Next, we're going to study continuity. And the idea behind continuity is the same as it was back in calculus 1. We want to make sure that the function exists, we want to make sure that the limit exists, and we want to make sure that the limit will be equal to the function. We're also going to find shortcuts of finding whether a function is continuous or not by using more or less the same rules that we use for limits. And then also, once we know that a function is continuous, then the sum and products of these functions will also be continuous. And the sum, the product, and then finally, if we get the composition of these things being continuous, then we can extend all those functions that we know to be continuous back in calculus 1 or in pre-calculus. We can extend them to studying here in multivariable calculus. And finally, we're going to take a look at limits and continuity for functions with more than two variables, 3 or more variables. And essentially, it's going to be the same idea. Instead of a little disk, or back in calculus 1, we look at a small interval. Here we're going to look at what we call a three-dimensional ball or a sphere. And so within the sphere, we're saying that the epsilon delta will satisfy the requirements that we need. But again, we're not going to dive too deeply into this. We're going to rely more on the limit rules and the continuity rules that we've established. All right, that is your overview for section 4.2. Good luck in this section.